Welcome to MyProjectBazaar.com. Now we are going to discuss about the title VLSI Computational Architecture for the Arithmetic Cosine Transform. Now we are going to discuss about the abstract of this title. Nowadays, the usage of discrete cosine transform is increased in this transformation. The requirement of floating point arithmetic and accumulate the round of errors. We are using the proposed arithmetic cosine transform. For accumulate the round of errors in floating point or arithmetic, this type of arithmetic cosine transforms are used. So thus in this process transformation, the round of errors will be accumulated, and by using this type of architecture will adopted in images and video coding applications. So many applications this type of architecture will be used. Thus by using this type of architecture in the transformation process will increases the performance speed and reduces the power consumption, then the area complexity will be reduced. Thus in this type of transformation process we are calculating the mean value and non-mean value. So this mean and non-mean value calculating for floating points will increases the transformation speed. So thus this type of architectures or will be used in many applications. Thus by using this type of architecture in the transformation process will increases the performance. Now we are going to discuss about the flow of this title. In this flow we are giving the 10-point input data, that is V0 to V10 as input to the null mean calculation unit and mean calculation unit. We are running we want to calculate the mean value and null mean value for the given input data. So in this null mean calculation unit there are add and shift multiplier circuits and adder units and subtractor units. So in this null mean calculation unit we are calculating the null mean value for the given input data and converting the 10-point input data into 8-point output data, and corresponding to this null mean calculation unit mean calculation block also running to calculate the mean value. Then for the given 10 input data the mean calculation will be calculated, and the output of the mean calculation block is given as input to the matters calculation block. So for this matters calculation block, this 8-point output data from the null mean calculation unit is as also given input to this. So finally the matter calculation block, the transformation process will be occurred, then we are obtaining the 8 final transformation output. So the 10-point input data is given to this models, and we are calculating the transformation process, and finally we obtain the 8 final transformation outputs. Now we are going to discuss about the running procedure of this title. So for that first we have to click to this ACT Xilinx IAC project. The programming window will be opened. In that programming window we can see the simulation and implementation results for this product. So first we have to click to this ACT. Now we are going to see the simulation result for this arithmetic and cosine transform. So for that we are click to this simulation and give simulate behavioral model. The simulation window will be opened. So in the simulation window we have given the 10 transformation inputs P1 to P10. So we are obtaining the 8 data point transferred outputs, that is OP1 to OP7. Finally we are given the 10 point data inputs to this AC to perform the arithmetic and cosine transform. Then we are obtaining the 8 output data, that is 8 transformation process. So by this process we are achieving the transformation process. So OP0 to OP7 is the final output data for this transformation process. So finally we are achieving the arithmetic and cosine transform. Then now we are going to see the implementation result of this arithmetic and cosine transform. For that we are click to this implementation design. Then give run to this synthesis report. So after running this synthesis existing, then we want to see the RTL schematic diagram. For that, click to this RTL view RTL schematic, then give run. Okay, and add give create schematic. Double click to this, zoom to full. This is our RTL schematic of this arithmetic and cosine transform. Then now we are going to see the technology schematic of this arithmetic and cosine transform architecture. For that we have to click to this view technology schematic and give run. Okay, add give create schematic. Double click to this US. Now we are given full zoom to this. So this is our technology schematic of this ACT architecture.